you read this opening statement, you read to understand it, ne? Bit by bit. You don't read the whole thing and then after that analyze after. This is what I mean. It says in the diagram, point A has coordinates -2 and 0. You look at it quickly. Point B 6 and 5. You look at it quickly. Point C 0 and -3. You look at it quickly. Now the fact that you've got the x coordinate of 0, it tells you that C is the y cut or the y-intercept of whatever line it is. In this case, line AC. Are we together? That C is the y cut. Yes. So you must make notes in pencil. C y cut. Make notes in pencil. You're gonna get asked something along the line C being y the y cut. Then D has coordinates xy. Okay, we have it there. Are vertices of a quadrilateral having AD parallel to BC. Now, first of all, what are vertices? A vertex is the corner of a shape. So if this is a triangle, this is a vertex, this is a vertex, this is a vertex. It's a corner. Okay. Now, vertices are corners. Singular, plural. Vertices are corners. These are vertices. Okay, sharp. And then now quad. What is a quad bike? A quad bike is a four-wheeled bike. Yeah, it's a bike with four wheels. So therefore, a quadrilateral is a four-sided shape. It could be a square, it could be a rhombus, it could be whatever it is. So a quad is a four-sided shape. And then the last statement here says AD is parallel to BC. AD parallel to BC. Another way in which they could have represented parallel is through these two lines. Okay, so you stop and look at your diagram. Where's AC? Where's AD? There's AD. Where's BC? There's BC. Those two lines are parallel. What can you guys tell me about parallel lines? What do they have in common? Yes, they go on forever. These two lines will go on 100%. The two lines will go on forever. They'll never meet. This one will go like this. This one will go like this. They'll never meet. Why? Because they have the same gradient, right? So, but if they're not parallel, this one would go like this, and then it will eventually meet this one. So, in a nutshell, gradient is just in a nutshell, two lines are parallel if they have the same gradient or they have the same slope. So essentially, if they ask you to find the gradient of AD, this line, and then you obviously have to use the gradient formula. But look at this, you don't have the coordinates of D. What you would do is that you just find the gradient of BC, and then after that, if the gradient of BC is 2, it means that the gradient of AD as well is 2 because they've got the same gradient or they're parallel. Are we together? Yes. So the gradient of AD is equal to the gradient of BC. Just make sure you put it in pencil so that when you answer the questions, you're sorted. Okay. Another way in which they could have said that these two lines are parallel is through these arrows here. Ne? These two arrows also tell us the two lines are parallel. So even if they hadn't mentioned this, you would have known what the two lines are parallel based on those two arrows there. Sharp. Then yes. Let's remove this. Okay. Sharp. And then they're going to say BA produced has an x-intercept of E. Where's E? Where's E? Where's E? Where's BA? BA. Here's BA. There's E. So they tell you that BA or AB, it's a line, this line, has an x-intercept of E. So can you guys tell me what is the y-coordinate of E? Can someone tell me the y-coordinate of E? It is on the x-axis. E lies on the x-axis. They made a mistake here. This is the x-axis, this is the y-axis. Can you guys tell me what are the coordinates of E? The y-coordinate of E. 0. Okay, you guys remember that anywhere on top of the x-axis, the y-coordinate is 0. You mustn't forget. Anywhere on top of the x-axis, the y-coordinate is 0. Oh God, did I mess this thing up? Come on, come back. Yes. Anywhere on top of the y-axis, the y-coordinate is 0. Don't forget that, again. And anywhere on top of the y-axis, the x-coordinate is 0. Don't forget that. Sharp. So I'm going to write 0 there. x1 and 0. X coordinate I don't have. Then they're going to say BD and AC intersect at M. BD, where's BD? Let us highlight BD quickly so that you guys can see what's going on. Here's BD, and AC. Here's AC. They intersect at M. Okay. You guys must anticipate M being the midpoint of either AC or BD. The fact that they use the letter M should give you an idea, or it could possibly be the midpoint, but you can't conclude because you don't have any like conclusive information there. So, but you must sort of think about it, consider it being a midpoint. Okay. Then the last one, worry, N has coordinates T and 0, right? So T and 0. So the fact that a Y there is 0 tells you this is the Y, this is the X intercept as well. Sharp. So this is the approach you must take when you're dealing with geometry. It could be analytical geometry or Euclidean geometry. You must have that approach. You must populate the diagram, read the statement bit by bit without rushing, and then populate the diagram as far as possible. You will actually see that whatever you get asked is what you would have populated on the diagram. Let's move now. The first question says calculate the gradient of BC. Where's BC? Here's my BC. All right. So you guys remember that we anticipated that since B and C are BC and AD are parallel, the chances are they might even ask you to find the gradient of AD as well. But let's find the gradient of BC quickly. This is the line we're looking for, the gradient. So we're gonna use the gradient formula. The gradient formula goes. Can you guys tell me what the gradient formula is? M BC equals. Can you guys tell me the gradient formula? Proper stuff. It's one of the most famous choruses in maths, the gradient formula. So now we're going to substitute the coordinates of B and C. Let's write down the coordinates of B on the side. The coordinates of B are 6 and 5, while those of C are 0 and -3. Now, you can take whichever answers your ones, whichever answers your twos. Let's take this as our twos, x2, y2, x1, y1. You can do it vice versa, it doesn't matter. You're going to get the same answer. You must, if you have a 2 here, you must also have a 2 there. Again, you can't have 2 then have a 1 there. You can't like have them mixed up. It's 2, 2, 1, 1, or 1, 1, 2, 2s. Okay. Sharp, sharp. Let's go ahead and substitute now into our formula. Gradient equal to, what is our y2? Our y2 is 5. Then the minus, this minus over there. Our y1 is -3. You mustn't forget the minuses. All over, what is our x2? Our x2 is 6. Minus our x1 is 0. This gives us 5 plus 3, which is 8, over 6, which is 4 over 3. So therefore, the gradient of BC is 4 over 3. Are we together? Proper stuff, proper stuff. Yes, yes, yes. The next question, 3.2, says determine the equation of AD. Yeah, yeah. AD is this straight line there, right? So now we know that AD is a straight line, right? So all straight lines are in the format y equals mx plus c, where m represents the gradient and c represents the y cut. Now, whenever they ask you to find the equation of a straight line, all you need to find is the value of m and the value of c. The value of m we already have. The value of m is 4 over 3. Why? Because AD is parallel to BC, so which means that they have the same gradient. So therefore, I can go ahead and substitute 4 over 3 there, like that. Are we together? Proper stuff. So now what we're left with is the value of C. How are you going to find C? You need to find any point that lies on the straight line AD. Any point. So fortunately we have the coordinates of A. Ne? So we're going to substitute the coordinates of A. Substitute the coordinates of A. They are -2 and 2. Ne? Your X is -2, your Y is 2. So you're going to substitute it in there, right? So my Y is 2. I put 2 in place of Y. 4 over 3. My X is -2 plus C. Remember that I'm looking for the value of C. The reason why I'm substituting because I'm looking for the value of C. This will give me 2 equals -8 over 3 plus C. I take the -8 over 3 to the other side, becomes a positive. Therefore, my C will be equal to 14 over 3. Do you guys get 14 over 3 when you punch? Proper stuff. So therefore, you can safely conclude now that the equation of the straight line AD is 4 over 3x. This is you substituting thingy there, plus 14 over 3. Any questions? Yes.